Yes, Alicia? What was it?
Can I say?
I said, what is internal resistance? What do you know about it?
No, I'm asking if I can say.
Yeah, yeah, please, please.
Internal resistance is the resistance in a battery.
In a battery, due to definitely due to liquid, and there are so many things inside it, but it's an internal resistance or the resistance of the cell itself, right? And
Right.
due to that resistance, definitely current has to pass through that resistance, and during passing through that resistance, that current has to pass through a potential drop. You can call that potential drop as lost volts, right?
Okay.
So that volts means V is equal to I small r.
Hmm.
So I told you previously in the last lecture that actually the voltage which is written on the battery, the voltage you will receive at the terminals of the battery will be two different things. Let's suppose if it's written 3 volt, then you can say EMF, which is actually equal to 3 volt, should be equal to IR plus I small r. Now, what is IR and what is I small r? If I write it in words, it means EMF equal to, this is what we called at voltage at the
Volt.
terminal voltage.
Yes. And lost voltage.
Yeah, plus the lost volts, right? So now you will have a
Right.
formula which is written here, E is equal to I into R plus 1. So now the terms which are here are terminal voltage, lost voltage, and total voltage, or you can say EMF. If you see the formula here, EMF is equal to terminal voltage plus the lost voltage. What will be the condition when EMF will be equal to terminal voltage?
An EMF equal to terminal voltage,
Yes.
then there is no internal resistance.
So when there is no internal resistance?
The battery's off.
Yes, when the battery is off, or when the current is not being taken from the battery. So it's written here, if you see that, the EMF is the potential across the terminal of the battery when no current is allowed to flow from it. This is also for your EMF equal to terminal voltage, as well as this is the, you can say, the voltage which is of the battery when there is no current is being taken out. Because once you take the current from here, it means that you're taking the current, means that there is a lost volts in there. Okay. So if somebody will ask you,
Okay.
when will this condition be that your your EMF will be equal to the terminal voltage, you will simply say that this is the condition when no current is being allowed to flow from it. Okay.
Okay.
There is a noise at the back. If possible, can you please?
Yes.
Because actually we are recording the lecture, so that's why I'm saying. So basically, this is the thing. So I want you to write this specific definition as well. This is the definition of EMF.
Where?
Yeah, I want you to write this, please. That one.
Okay.
This is the definition of your EMF. When is the condition? So see, if you see this formula means terminal voltage equal to EMF minus the lost volts.
So in an exam, if they ask what is the definition of a EMF, this is what you write.
Yeah, that's it. EMF is the potential difference across the terminal of the battery when no current is drawn to flow from it. And no current is allowed to flow from it. If they ask you what is the terminal voltage, then you can say terminal voltage is the voltage that is actually achieved or you obtain at the terminals of the battery. And this is mathematically equal to the EMF minus the lost voltage.
Say again for terminal voltage.
Yeah, so terminal voltage is actually equal to mathematically EMF minus the loss volts. Mathematically. All right. Understood? Shall we move?
Okay. Yeah.
Okay. Now let's see some of the past paper style questions in this, and then we will further go into the detail of sequence and series resistance. Now check this out. Don't see the solution on the right hand side. Question is they are saying is with the switch S open, the voltmeter. Wait, let me just rub that and then we solve it. They say with the switch S open, the voltmeter, which has a very high resistance, reads 12 volts. It means that initially when the voltmeter, they're saying when the switch is open. Now, if you remember, I've told you in the first lecture, when switch is open, the voltage will be maximum because the resistance will be maximum. So in that
Maximum.
case, so if resistance is maximum, it means no current is flowing through it. So voltmeter shows a full-fledged reading, which is equal to 12 volt, right?
Right.
So it means that at that point, the voltage is maximum, which is 12 volt. What they're saying is after it is closed, now the switch is closed, the reading falls to 9.5 and then rises shortly after to 10 volts. So what exactly they are saying, given that given the 10 ohm resistance in the diagram is initially at 0 degree, why does the voltmeter reading shows 12 volt with S open?
Because at S the resistance is at maximum, or otherwise it is at infinity, and the voltage would therefore be maximum because they are inversely proportional.
No, there is
Sorry,
directly one.
directly proportional.
See, one point is that, and the second point is while the switch is open, so actually no current is drawn from the battery. And when there is no current drawn from the battery, there will no lost voltage. That's the reason whatever volts are actually this particular battery belongs to, that will be shown on the voltmeter. So this thing you have to add it as well because no current is flowing through. Because if the current start flowing, then there is a problem. So one reason
Okay.
is the switch is open. So whatever the voltage will be is voltage across the voltmeter. Plus, the one more important thing is that in this circuit, because no current is drawn, and because no current is drawn, it means that no internal resistance is involved in it. So no lost voltage. It means that total voltage is shown on the voltmeter. All right.
Okay. Yeah.
Now, next part is very interesting. What is the value of R initially? Now, you tell me, if you see this circuit, how will you find out the resistance value? The resistance value is
Um,
very interesting. Yeah, you're saying something?
First, I would find the current
Yes.
from looking at the battery, and therefore it should be the same in the resistor because it's in series.
See, the first point is very interesting. You need to find the value which is it is reduced, right? Because the formula is basically, if you see that, voltage is equal to EMF minus the lost volts. So what they're saying is, if you read the question, they say after it is closed, the reading falls to 9.5. So point is, if reading falls to 9.5, what is the current passing through? The current will be passing through how much? So basically, EMF, I mean, 12 volts minus 9.5, what it exactly comes to? 2.5. This is the voltage which actually called as lost voltage. This one. Now this lost voltage have the current because whatever current is there is passing through the resistor, as well as this is the same current which is passing through the main resistor. So can I say that V is equal to I R plus small r? This is
Say
the
again.
See, this is a formula to find out this IR will be your terminal voltage and this IR will be your lost voltage. We have already seen V is equal to, this V is basically EMF, and this will be equal to terminal voltage plus the lost volts. And there is a way of writing this. Okay. Now point is, how will you find this current value? Very interesting. You need to find the lost volts. So lost volt is, they say this will, this particular voltage reduced to 9.5. So how much reduced? 12 minus 9.5, which is equal to 2.5. Now this is the voltage which is actually across this resistor. Now we know
Okay.
that in a series circuit, the current will be the same. If you by chance find out the current passing through this resistor, it will be from the current. So what exactly it is? Simple as that. You already found this voltage. So basically I will be equal to V upon R. So what is V? V is 2.5 lost volts divided by the resistance, which is 0.7. So this is equal to 3.33 amperes.
Okay.
So you found out the current through the lost volts. And whatever current which is actually involved in the lost volt, it is the current which is passing through the circuit.
Mm,
All right. Now you need
right.
to find the value of R. Now you can use that formula because we found out I value. So basically, this V means the total volts, 12. I means 3.33. R we
Okay.
do not know, but a small r we found out as 0.75. Now very simple. 12 divided by 3.33, how much it is?
Um, 12 divided by 3.33 is 3.6.
Minus 0.75.
2.85.
So this is the resistance value of that resistor.
Yes.
Very simple, not difficult.
So recap, first you found the lost volts
See, in
by
this kind,
subtracting
I tell you, I
9.5.
I will rub it so that you will understand. See, the first thing is because we do not know this resistance, actual formula for the voltage to find out the current is V is equal to I into R plus R. Now, how many things are known? Check it out. You know this volts, which is actually 12.
Yes.
You do not know this resistance, you know that resistance, and you do not know this current. So basically, you are unknown by two values. One is I and one is capital R. You have to find these two values by any chance. R, you have to find it. Only thing you need is I. Now, one thing is
Yeah.
very interesting. If you see that, they say that the voltage is 12 volt and it is reduced to 9.5. My question is, Because 0.75 resistance is in series with the capital R. So can I do one thing? I will find out the current from 0.75 because that current will be same for R as well. It's a series.
Yeah.
So what did I do? I found out the lost voltage, which is actually equal to 12 minus 9.5,
9.5.
which is equal to how much? 2.5.
2.5.
Now this is that voltage actually, this volts. Okay.
Yes.
So once you find this volts, we know the voltage, we know the resistance. So why not go for the current? I is equal to V upon R. So it is 2.5 divided by R, which is 0.75. When you did it, it's coming up as 3.33 amperes.
Yes.
Now this ampere will be same for R as well because the circuit is series circuit. Okay.
Yes.
Now you can use the above formula to find out R. Simple. V is equal to 12. I is equal to 3.33. R is R and small r is 0.75. Manipulate it and you will find the value for R. Is
Yeah,
this
it was
8.5?
2.85.
Understood?
Yes.
Good.
The part C says, what is the value of the current after a short time?
After a short time. After a short time, they say the voltage is reduced to 9.5 first and then it is increased to 10 volts. So now find out the internal resistance or loss volts and then find out the current. So it will be how much?
2 volts.
It will be
12
2.
minus
So 2 divided by the resistance is 0.75. What is the value?
um it is 8/3, 2.6 occurring.
So now the current value will be 2.67.
Is that it?
That's it. Done.
Okay.
Because what it means is actually, it means is that initially the voltage was 2.5. It means that resistance were more. Then slowly but surely resistance reduces a bit. When resistance will reduce, the current will increase. No, current is actually, in that case, the because the value was 2.5 divided by the small value of the current. So here the current was more. Now slowly but surely the value reduces. The current value reduces. Okay, in that specific case.
Okay.
Now next is what has happened to the value of R. Explain why. R value is what? Initially it was 2.85. Then what happened?
2.85 and then it became 2.
No, it's not resistance which is changing, but what they are saying is what happened to the value of R and explain. Like after a short time, when the so basically if I has now you if you check this out, here the I was 3.33. Now I is reduced to 2.67. I have told you
That
previously
increased.
if current reduces,
Resistance has increased.
yes, it simple means that the reason is changing in the temperature from 0 degree. So it means that the temperature rised, and as the temperature rise, it's no more 0 degree centigrade, and resistance of the resistor increase with the temperature.
But something doesn't make sense. In part B, we found that the voltage is equal to 2.5. Therefore, we find out that the current is 3.33. But in part C, the voltage has reduced and the current has reduced.
No, no,
But
current.
I
See, current. It's not like this current is reduced. They're just giving us a scenario in this. What they wanted to wait. Okay. The simple thing in that case is listen again. The point actually is resistance will increase anyway. But this resistance and the resistance you're talking about are two different ones. Initially, it will take too much amount of current because when you turn it on, it was very new. So initially, the total internal resistance will be a bit small because current will be more.
okay.
It's same like that. that when you buy a shoes for yourself, initially it will disturb your foot. Sometimes your foot will not fit into that. But as the time passes, you are becoming used to that, and the shoe will be becoming used to you as well. So initially, when you turn on the battery, it was a new battery. Everything is new. Everything is absolutely fit. So it start taking too much amount of current. When current is more, resistance will be less, and when resistance will be less, the voltage will be less, because we don't want this loss voltage to be at the top. You understand what I'm saying? Initially,
Yeah.
there is too much current. Remember that. But as the time progresses, resistance start increasing. When resistance start increasing, the voltage or lost volts also start increasing too. Okay, this is the case. But in that scenario, what they give us to her, this is just a question. They say initially the voltage or loss voltage is 2.5. Then they say the voltage actually reduced. We know that voltage reduce should means current increase, but again in that case they are not talking about just one path. They are not talking about the current through the internal resistance, but they are talking about the total current of the circuit. Remember that the current you are
Okay.
founding is not the only current passing through the internal resistance. It's not just internal resistance, but it is also the current passing through the capital R as well. That is the reason initially the current increases, then current reduces. As far as voltage is concerned, this is the scenario of the battery they give us.
Okay.
Okay? So don't be confused with the words or with the values. Important thing is battery thing is not in our hand. Its voltage increase or reduce, but the total current value is in our hands. It simple means that our value is also changing.
Okay.
Because you see one thing in the question, if you see that they say if it is close, the reading fall to 9.5. Initially, the voltage reduces and then afterward it becomes to 10. Now, does it make sense to you that initially the voltage is reduced to a some value and then technically speaking the voltage again come back to 10? Might be there is some battery which shows this characteristics and they put it in the question, because practically the things are different than the theoretical things.
Hmm.
You understand what I'm saying? So don't be like
Yes.
confused and say doesn't make any sense, because thing is sometimes the things which doesn't make sense are in real, because the reality is a bit different than the calculation things. Understand me? That's what I'm saying. Shall we move on?
Yes. Yeah.
Okay, let's go to the next part of this. Where is it? Wait. Okay, now this is another circuit, but this is a, wait, let me just rub that. Okay, they give us the standard of a paper as well, like what type of question and what type of people are they giving what type of resistance. Now, first important thing, they are giving us a circuit along with a diode in this, and they show our resistance. Wait, let me rub that. First important thing, not this one. I actually wanted to come to this question, which is very good question in the end. We will come to this in a bit. Okay, explain the following terms. Internal resistance. How do you explain that?
You just told me it is when the PD across the terminal of a battery um has no wait.
It is just you have to say
My
it's
definition doesn't make sense. What I wrote was the voltage across uh, the terminal of a battery
it's not
when no current is allowed to flow from it.
no, 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 but you're telling me about the voltages. They're saying only internal resistance. So you have to say that internal resistance is the opposition offered by the battery to the flow of the charges through it. That's it. It's
Wait,
internal resistance.
internal
Resistance
is the opposition
offered by the cell
offered
by the
by
cell
the
cell
cells
to the flow of charges, flow of charges,
to the
flow of
flow
charges, of charges
charge.
in the bracket write current inside the cell.
Okay.
This is what the internal resistance is. You can manipulate this statement by any way, but important thing is it is the resistance offered by the cell to the flow of current inside the cell. Remember that. Now, what is lost voltage?
Lost voltage is the voltage which is not used, that is dissipated.
You can say two things in that. This is a voltage which is not available to the circuit in which the cell is connected, plus it is the voltage across the internal resistance.
Voltage across the internal resistance.
Yeah.
Lost voltage is the voltage across the internal resistance.
And it is not available to the circuit in which the cell is connected because this is consumed inside the cell, right? Now the next
And that you just said, which is not available to the circuit.
to the circuit in which the cell is connected.
Okay.
All right. Now important thing, the next. What is terminal potential difference?
The opposite of lost voltage. It is the voltage which is available to the circuit.
Or you can say the voltage at the external or at the terminals of the battery, at the terminals of the cell, external to the cell. The one you just said it will be in the same way. A terminal potential is the terminal, it's a potential across the circuit external to the cell. All right.
Yeah.
Now, next is electromotive force. Just write the definition by the formula. Electromotive force is the total volts of the cell at the terminal or total voltage of the cell supplied to the external circuit plus the internal. Sorry. You can write two things in that. I want you to write it, I think. EMF is the total voltage.
It is the total voltage
Supplied to
of the
the
cell.
supplied to external circuit and the internal resistance.
Okay.
One formula is that, and another one is EMF is the sum of
EMF is the sum of
terminal voltage and lost voltage. Now the next is under what condition are the EMF and terminal potential equal? We have just discussed that.
sorry, what did you say?
What will be the condition when EMF and terminal potentials are equal?
The current, sorry, there's no current being drawn
Yes, simple.
from the
When
cell.
when there is no current drawn from the battery, that condition is called as when EMF will be equal to the terminal potential. Right? Now, next point is what
Yeah.
is the fundamental laws of Kirchhoff 1 and 2 laws based on? One was con conservation of charges, and second is conservation of energy.
Okay.
Yes, Alicia, you're there?
Yes, sir, I'm here. Just my thought was bad, so I had to leave for a while.
Okay, that's all right. So you understood everything, the basics of this internal resistance and everything?
Mm,
Yeah, if I have doubt, I'll like rewatch the recording.
Okay. So recording is clear, everything is all right with this?
Yeah.
Okay.
so first law is conservation of charge. Second is conservation of energy.
The first one, if you remember, was the total current in is equal to the total current out of 1 point, right? That's the reason it's a conservation of charges, while the second one is related to the energy.
Yes.
Now, I would just want to go with the series parallel circuits now. Let's do some calculation, and this will be the last part of this chapter. Then we will hopefully, if you understand that in this class, that's fine. Otherwise, we will continue in the next class, and then we will jump to the waves, the topic we are on with the Mahanur, and hopefully in the next week, once you join her, we will be
I
start.
have I have one important question. There is a topic that is not in our unit, but it is across all units, and they always ask for every topic. I am really bad with the uncertainties and measurements
Measurements. Okay, we will see to it. Don't worry about this. Once we
because
come.
I
Mhm.
I have
See,
one specific issue.
no problem. We will see to it. Once we complete our unit one and the other unit, hopefully we will jump to measurements, whatever you will say. That one will be the choice thing from your side. All right? Will that be fine?
What do you mean by we will do unit one as well?
Yeah, yeah. Once we finish with this electricity, rather than jumping to the wave, we are doing waves actually. So you will be actually joining her Mahnur with might be possible you are joining her with photoelectric effect.
Okay.
Hopefully you will be reached till there. And if, for example, by any chance something left, for example, behind, then we may take one or two extra classes. We will see to it later on. But you will join hopefully to her somewhere at photoelectric effect. All right.
Also, sir,
Okay.
we only have one topic left for electricity, like one lesson.
Yeah, it's just sequence and series left. The calculation work is left.
Oh, so by
Uh,
like today, we'll finish it.
It depends on you if you will be able to solve me some sequence and sorry,
Oh, okay,
not
okay.
sequence series and parallel circuits.
Parallel.
Then
Yeah, okay.
so I will.
So, sir,
Yeah, yes,
sir, by today, could you give us some like past paper questions or something like I don't know, a
From
worksheet?
I will give you question. Don't worry. It's
Okay.
related to the past paper. Definitely, don't worry. You know why I'm
um
not. Why I'm not taking you to past paper. There is a reason. I want to finish one complete topic and then we will be jumping on the past paper and firing on the past paper.
Yeah,
If
yeah,
if
I
I take you
understand.
to now, then one part you may know and one part I have to tell you again. It's no use. You understand me what I'm saying? Okay.
Yeah.
okay.
Now let's quickly see how many types of circuits you have. You got two types of circuits. One is called series and the other one is called parallel circuits. Let's see the characteristics of series circuit. Let's talk about this. Let's take these two resistance and there is a battery connected. This is R1, this is R2, and this is your V. Now, my point is if the current is coming out of the battery, let's take it as I. How many paths this current has?
One.
One path. It means that current through R1 and current through R2 will be the same. Am I right?
Yes.
So, can I say that total current of the battery is equal to current passing through each resistor. Can I say that?
Yes.
Or in other words, if I write it an equation, I is equal to I1 is equal to I2.
Yes.
Okay. If you understand that now in series, you got a resistance here. So current will pass. So there will be a voltage of V1 and there will be a voltage of V2. So at each
Mhm.
point, whenever the current will pass, the voltage will be reduced. So can I write it that V will be equal to V1 plus V2?
Yeah.
And this particular equation is also called as potential divider. Another equation is called potential divider, but we can say a series circuit as a potential divider as well.
Yeah.
Okay,
Today we did a question in class and I
is it?
have an idea that
You will have an idea.
two
Yeah.
resistors are the same as one large resistor with um an with an additional resistor through the middle of it.
Okay. We will do the question. You will understand as further. Just let's like let it go. So here in the series circuit, the total voltage will be divided into voltage across each resistor, right?
Right.
Now, one of my question is, when the current is coming out of the voltage battery, do you think the voltage knows that this is R1 resistance or this is R2 resistance?
No.
What the battery is actually looking at, battery looks at the combined effect of the resistance. What is a combined effect of this? So combined effect of the resistance is called as R effective, or you can say effective resistance. So actually your battery sees at effective resistance. Sometimes we do call it total resistance or equivalent resistance. In A levels, we called it effective resistance. In O levels, we called it equivalent or total resistance. So I think you better say it effective resistance.
No, we also say total resistance.
Okay, up to you. But there is a reason why I am saying don't say total resistance. You will find out in a bit in the same class. There is a reason because total normally what people think is that total resistance always mean the sum, but it's not always the sum. Now let's find out the equivalent resistance. Let's assume that now you are replaced this full resistance by a single resistor, and I want to find out the resistance of this resistance R, which gives me the combined effect of this R1 and R2. Okay, let's do that. We know that V is equal to VI plus V2, right? We know
Mm.
that V is equal to IR. So let's place the values here. IR here, I1 R1 here, I2 R2 here. We already established the fact that total current is equal to I1 is equal to I2. So let's place I here and I here. So basically, you can take I common from that side. So what left behind is I and I will cancel. So your R effective will be equal to R1 plus R2. It means that in series resistance, the combined effect can be found out by the sum of the resistance. So you add all the resistances and you find out the combined effect of the resistance. Understood?
Yes.
Now I want you to try a question here. First, I will do it for
Wait,
you, then.
sir, you said that we shouldn't call it total resistance because most people assume that it's a sum.
Then
So why
I, t-
should we?
I tell you one thing. See, in series resistance, it is always sum, right? But when we do the parallel circuits, you will find out that there it's not sum. There the formula is different. That's why I normally do not recommend my student to call this a total resistance because they be confused. What comes in your mind as a total means always a sum. You understand me what I'm saying? But
Yeah.
you
Yeah.
don't be that's why I'm saving you people from confusion rather than saying a total resistance, call it equivalent resistance. Okay. By the way, you
Mm,
can use total resistance. That's not an issue. If the confusion is not in your mind that total resistance is not always a sum, then use it. No issues.
okay.
Mm.
All right. Now let's solve one of the question from series and then we will proceed to parallel circuits. These are your two resistances. It can be three. The voltage is 5 volts. This is your 2 ohms resistance. This is your 7 ohms resistor. What do you need? What they ask you for to find out? They are saying find V1, that is voltage of V1, V2. This is R1, which is given to you. This is R2, which is given to you. And they are asking you I1, I2, and R equivalent. So altogether, you have to find total 5 unknowns. All right. Now, what is the
Yeah.
first step to? Yeah, you're saying something.
I'm back. Sorry, I could not hear for a bit. Can you repeat what did you just explain?
I was just explaining a question that in this question you got two resistances and a voltage V which is 5 volt is connected. Now you have to find out the voltage across each resistance, that is V1 and V2. Then you have to find out the current of each resistance I1 and I2 and R equivalent. All right.
Mm.
Now always remember to solve these kind of questions. You can start by two ways, especially in series circuit. You know, when the voltage is given to you, the total voltage and resistors are given, V1 is very easy to find. You know how?
The ratios.
We can use potential divider formula.
There's
Now,
a
what is,
formula.
yeah, potential divider formula. Now, what is it? Let's see. Let's do V1 first. V1 means voltage across R1. How do you find out? This is R1. So put it on the top, divided by the sum of R1 and R2, multiply by the total volts, which is 5 in that case. This is the formula of V1. What about V2, Zoha?
V2.
The resist.
R2 over R1 plus R2 times V.
Yes. It will give you direct volts.
Oh.
So 2 divided by 2 plus 7, which is 9, multiply by 5. What is the value?
Let me see. For the first one, V1 is 1.1.
By the way, do you really need to use this formula or you can directly find out the voltage as well?
I just need to change 2 to 7.
No. You can. That's what I'm saying. But you can directly find out the voltage of V2 as well. Why? I tell you how. Some voltage is dropped over here. The rest of the voltage will drop from to at
So
this. So why not use
5 minus 1.1.
That's it. So you will get 3.9 volts. You can use the formula as well. That's not an issue. You will get the same value. Check it out.
Yeah,
Check
you
it
get
out. 7 upon, yeah.
3.89.
So,
Uh,
now-
Sir, the way I did this question was I didn't use the potential divider formula. I just like calculated the total current in the circuit
Yep, you can
and
do
then
that.
I multiplied.
You know why I told you this formula? There is a reason. Because now potential divider formula is in your course. So if you
Oh,
want to
okay.
use it, you can use it. Otherwise, you have a traditional conventional method in which you have to
Yeah.
find the equivalent resistance first.
Yeah.
Now, what is equivalent resistance? First of all, what circuit is it? It's a series circuit, right? So draw that circuit just with one resistance. So the total resistance will be 2 plus 7, which is equal to 9 ohms. So,
Nice.
so that value is 9. Voltage is 5 volts. Now you can find out the total current. So I is equal to V upon R. So 5 divided by 9. Alicia, what is the value coming up?
0.56.
0.56. Now this current is total current and this is equal to I1 as well. And this is equal to I2 as well because this is a series circuit.
Yeah.
Now once you find out, simply V1 is equal to I1 R1. So it will be 0.56 multiplied by 2. And the other one is V2 is equal to I2 R2, which is equal to 0.56 multiplied by 7. And it will
Yeah.
give you the same values.
Yeah.
This is the traditional method of solving same kind of questions.
Yeah.
So if you feel easy to solve in this way, no problem. Continue with that. But you should know the potential divider formula as well, because sometimes potential divider makes your life very easy.
I like the formula because today we were marking a question and I couldn't understand why we had to do exactly what was in the formula because we weren't told that it was a formula. We just thought that the logic behind it, but I didn't like that because I would forget. This makes it much easier.
Okay, whatever you think is easier, you will go with that. Don't worry. But as a tutor, as a mentor, my duty was to tell you both the ways. Now it's up to you which way you select. I mostly prefer the second method, the traditional method as well, because my students prefer the second method and they are saying not to tell them the potential divider formula, but I had to because this is in our course technically. Okay.
Okay.
You will find the question related to the potential divider in the course. That's the reason I just want them to say, okay, take it as a practice, and at least you should know the things how we are solving it. You're not solving by that way, no issues. So shall we move on to parallel circuits?
Yes.
Okay, now the parallel circuit. Now you will find out why I am saying that why not use this total resistance. There is a reason. Check it out. Parallel circuit is just like that. This is one resistance, the other resistance. This is R1, this is R2, this is V. Now, if you check it out, when the current reaches to this point, it will have two paths, one from here and one from here. So here it will be I1, here it will be I2. At this point, they will again combine and it will go into the voltage source. So can I say that I
Uh,
is equal to
well,
I1 plus I2?
yes.
Why I say that? Because actually we know that Kirchhoff's first rule, total current
Law,
in must be total current out.
law conservation of charge.
Yes. Understood?
Yes.
Now we can see that in parallel circuit, these 2 points are constant for all the resistance connected in parallel. So can I say that V is equal to V1 is equal to V2? Because the 2 points are common for all the resistors.
Yes.
Now let's find out the combined effect of the resistance. Like if I connect one resistor, what will happen? What will be the R effective of that? So for that reason, let's see I is equal to I1 plus I2. Now we know that V is equal to IR. So I is equal to V upon R. Alicia, just a second. Zohar, just a second. Okay. I have a call to attend. Just a second. Okay. Understood?
Yes.
So now I will simply place these values in the equation. So V upon R is equal to V1 upon R1 plus V2 upon R2. Now, as per the formula, V is equal to V1 is equal to R2. So I can say that V upon R1 plus V upon R2. So you can take V is equal to V upon R is equal to, I can take V as a common, so 1 upon R1 plus 1 upon R2. So V cancel. Did you notice one thing? You got a new formula which is saying 1 upon R is equal to 1 upon R1 plus 1 upon R2. Now, can you say
Yes.
that equivalent resistance will be the total resistance of the circuit? You know, total
No.
normally, because total normally means addition. Whenever I say what is the
Yeah.
total amount, total means the sum. But this is not the sum. That's the problem. That's the reason I normally refrain for, calling these as a total resistance rather than I call them equivalent resistance.
Yes.
Now, one more
That
thing.
makes.
Okay. One more thing. This formula is difficult to solve. So you rather find out the resistance by using this formula. R is equal to R1 multiplied by R2 divided by R1 plus R2. This is more refined form for finding the R resistance or R equivalent.
Is it R1 times R2
Yes.
or R1 plus R2?
This is easy to apply. Otherwise, you have to put the values in. Sometime you have to find the values, then you have to invert it. It will take a bit of time. Here, you can simply put the values in the formula and get the answer.
How did you get this formula? How do you derive what we
See,
first have to that?
check it out. What is the LCM of that?
Um,
If
R.
if nothing is common, you multiply them. So R1 cancel, you will get R2. R2 cancel, so it is R1. So 1 upon R is equal to R2 plus R1 divided by R1 plus R1 into R2. If you revert it, it will be R1 R2 divided by R1 plus R2. It's the same thing.
Yes.
So I gave you a direct formula rather than you solve it or whatever you do.
Hmm. Oh,
Okay, understood?
yes.
Now you found out the equivalent resistance formula or R effective formula in this. Now let's solve one of the questions. There is a battery connected to that. This is 2 ohms. This is, let's take it as 20 ohms. R1,
R2.
R2. Now I want you to find out what is V1 and what is V2 first of all, quickly.
Um, it will be 5 on each.
Yes. Now, what you want me to find out? R equivalent. Always start with R equivalent. This is the formula, you have it.
Yeah, I'll just put it in the calculator.
Is it 2.5?
Is it? I didn't know that. Zoha, can you check it out?
Um,
It's
it's
4.
1.8 on my side.
What about
Oh,
you?
never mind. Never mind. Yeah, because I used the wrong values. Yeah, yeah. Zuha's
Okay.
right.
Okay. Did you notice one thing? In the series circuit, the equivalent resistance was more than the individual resistances, and here the equivalent resistance is less than the individual resistance even.
Yes.
So you can
Yes.
say that in series circuit, the total current value will be increasing or reducing.
Reducing.
Reducing, and here
Increasing.
increasing. And that value then afterwards break up into each resistor because they are in parallel circuit. That is a reason,
So what does it make?
the significance is that is a reason in our home, in our house, we do not use the series circuit, but we used a parallel circuit. All right.
Hmm.
Another significance, because for battery it will be easy because battery faces the less resistance as compared to the series resistance as a combined resistance. Okay, once you find out the equivalent resistance, now put this single resistance instead of these two resistances and connect with the battery. So R value will be equal to 1.8 ohms and the voltage is 5. Find the total current, which is equal to I equals to V upon R. So V will be equal to what? 5, and the total or combined effect is 1.8. What is the current value?
Um, it's 2.78.
2.78. Now, important thing. This is the total current of the battery. Remember that. Your current value will not exceed this 2.78 value by any chance for I1 or either for I2. It can be same, but it cannot be more than 2.781. Now let's start with this. The total current is this. Not once the current reaches here, it will be break up into R1 and R2. So very easy. I1 equal to V1 upon R1. V1 is 5 and R1 is 2. So the value is 2.5. And for I2, V2 upon R2, 20 divided by, is it 20? No, it's 5. 5 divided by 20. What is the value?
0.25.
0.25. That's it. Sorted.
Okay.
Understood? Easy?
Yes.
Because once you finish with this, I will show you the circuits in which there is a series as well as parallel circuits in one circuit. Okay, these are two resistances. R1 equal to 4 ohms, R2 equal to 7 ohms, and total voltage is 5 volts. I want you to find me I1, I2, and R equivalent. Take your time and just give me 1 minute. I'll drink and I'll be back. You just continue. and this is 4 ohms. And now you will have a resistance of 5 volt. For the time being, I want you to find out each and everything, okay? So let's start with I1, I2, I3, V1, V2, V3, and R equivalent. Now, how will you proceed with this question? Did we solve these kind of question in the school?
Yes,
So how
in
to start?
exams.
So how to start with this?
First, decide which one is going to be my series circuit and parallel circuit.
See, the very simple rule is always start from the most farthest resistances where you find the most farthest resistance. So which two resistance are the most far away resistance from the battery actually?
R2 and R3.
So what is this combination R2 and R3?
Parallel.
No, yeah, it is parallel,
Series.
absolutely. Because here and here, they are the two common points of these resistance. So here I mention it. Always find out the R equivalent first. Without that, you cannot find I1, I2, or R3. Okay. So we will write it here since R2 and R3 are in parallel. So now I'm using the combination as the name R2, 3, R1, 2, something like that, so that it will be understandable for me that it is a combination of R2 and R3. So what is the formula for R23? R2, R3
R3
divided by,
R2 plus 3.
can you find me these values, please?
Yes. That's 6, right?
It is not 6.
No. As in R2 is 6 ohms.
Yeah, it is 6 ohms.
Is
It
it
should be
1.5?
1.5. Yeah,
What is the value?
1.5.
1.5.
1.5. Now remember one thing here, the next diagram will be essential. You have to draw it. How do you do this? You remove these two resistance and instead of these two resistance, you will place R23 resistance. In other words, the new circuit will be like this. So your R1 resistance is here, which is 4 ohms. And your R23 resistance will be 1.5 ohms. That is your circuit 1. This is your circuit 2, technically. I'm just putting a name on that. So the thing's going to be easy for me afterwards. Now you tell me, what about R1 and R23? What is this combination?
R effective will equal R1 plus R2.
3. R23.
R2 3.
So I will mention it since R1 and
It will be
R23
5.5.
are in series. So R effective R123 will be equal to 4 plus 1.5, which is equal to 5.5. So now the last of my circuit will be single resistance, single battery. That's where actually I have to achieve all the time.
Oh.
This is your 5 volts. Once you reach to this point, you actually found out the R equivalent till here. So one part is done. From here, you have to backstab. Backstab means you have to jump back to your previous diagram. Now you tell me your R equivalent or your R12. What is this combination? R123.
2, 3. It's
a series combination of R1 and R23. Am I right?
yes.
So you have to mention it since R123 is the series combination of R1 and R2, 3. Let's find out the current first. Current will be equal to V upon R. So V is 5, R is 5.5. So what is the value of the current?
Uh, 0.9.
Now you tell me this is the total current, and we know that in series, the total current will be the current through each resistor. Am I right?
Yes.
Yeah.
So can I say that I is equal to I1 is equal to I23 is equal to 0.9? Can I say that?
Hmm.
Understand this?
Yeah.
Yes.
Okay, now I1 is known. So you can very easily find out V1 anyway. V1 is equal to I1 into R1. So it will be 0.9 multiplied by R1, which is how much is it? 4. So what is the voltage?
3.6.
So one resistor is sorted. Till here, I don't think so there is any problem. Now in the series
No.
circuit, you will see always find out all the three physical quantities. We have known V1, I1 and R1. Same way, we know I23, we know R23, but we do not know V23. Let's find out V23 as well. So V23 is equal to I23 into R23. So I23 is 0.9 multiplied by 1.5. So what is the value?
1.35.
Now check one thing if you don't think. Because these two are in series, so their voltages, individual voltages should be, if you add them, should be equal to the total voltage. If you add these two, you will came across nearly 5 volts. Nearly.
Yeah, 4.95.
Because you took a decimal value, so decimal value will always be like. Now, we further want to know I2 and I3 values. So you have to shift back again. You tell me what is this R2 and 3 combination? It is the parallel combination of R2 and R3.
Yes.
So can I write it? Since, where is my diagram? Yeah, since R2 and R3 are the parallel combination of R2, 3. So if they are parallel, what is happening? What is the quantity which will be same?
Current.
No, in parallel circuit, voltage remains the same.
Voltage.
So V23 is equal to V2 is equal to V3, and that will be equal to how much? 1.35. Now we found out V2 and V3. Now I think it's time to find out the current I2 first. So I2 is equal to V2 over R2. So V2 is how much? 1.35. And what is R2? R2 is 6 and R3 will be 2. So this will be 6. What is the value? And V3 will be R2 upon R3, which is 1.35 divided by 2. What is this value and what is that value?
Sir, can you repeat the last part?
See, last part is very simple. Always remember you have to find out the all the voltages here. We find out V1 first, but didn't we find out the series combination, which is this resistance, which is R23. So what did I do? I found out V23 as well because I knew the values. I knew I23. So I used that value to find out V23, which is 1.35. Then I say, because I have to find out I23 and V23, I say that R2 and R3 are the parallel combination because they are parallel combination. So I knew that in parallel combination, the voltage will be equal individual voltage will be equal to the voltage across each resistance. So V23 will be equal to V2 and V3. All right. So because once you find out the individual voltages, now current will be easily, you can find out I2 is equal to V2 upon R2, and I3 will be easily, you can find out as V3 upon I3. What are the values?
For I2 it's
0.225.
0.225, and then for I3 it's 0.675.
That's it.
Yeah, 675, not
675. This is long
I
question,
just said,
right?
yeah.
But remember that in your questions which are coming in your examination, you do
Oh
not
yeah.
have, you
If
don't
it,
have, yeah, you don't have to find everything. They will ask you
yeah.
to find certain things. But for the practice, we are doing every single thing, unknown things to be found. So don't worry about if you look like, if you feel like it's a long question, because the question will be smaller anyway. This is just for the practice. Okay.
Okay.
Do you understand? Are you ready to do one question like that?
Yeah.
Yeah.
Okay. Let's try then. You got a circuit like this. This is R1, R2, R3. This value is 2 ohms. This value is 3 ohms. And this value is 5 ohms. I want you to find me I3, V2. And at this time, I'm introducing a new thing called, now what is this thing? First R equivalent. And one more thing, power consumption of R1. Now what is it? I will explain in a bit. Power, there is a
P,
formula.
I,
P is equal to VI, or P is equal to I square R, or P is equal to V square R. These are the three formulas. You can use any formula as per your requirement, and you will put the values of voltage or current voltage or whatever to find out the power of the resistance R1. How much power is consumed? Technically, power will be equal to work done upon time, but this is the electric power. These are the three formulas. Like for example, you already know the R value. So you better find out V1, or you better find I, to just put the value in, I mean, put the values of the, the non-quantities and use the value to find out P. Can you do that?
yes.
Try that.
So did you purposely not give the EMF?
What again? EMF is 5 volts.
Did
Let's take it as 5 volts.